discuss relative velocity with two approach. First of all, from our general observation point of view, and second from a mathematical point of view, that is reference frame. With the help of reference frame, we will discuss relative velocity systematically. And before that, as you are observing velocities and motion in your daily life also, so you must understand this relative velocity concept based on your daily observations. Then you will appreciate it, because when you will feel that whatever you observe and that observation, you are convinced with that observation from relative velocity point of view. So first of all, we will discuss about general observations and how relative velocity is defined based on general observations, day-to-day observations. So relative velocity, we write term VAB. Relative velocity is represented with this representation VAB. That means velocity of A. This A can be any object or frame or anything whose motion can be observed. Velocity of A relative to B. Velocity of A relative to B is represented with VAB. So what does it mean actually? So we will take simple example. So let this is a card. This is a card and a person sitting inside this card. This is observer 1. Observer 1 is sitting inside this card. And this card has a ball. Ball B. Ball is represented by B. And there is ground, another frame which is ground, earth. That is the earth. And another observer sitting on earth. Let this is observer 2. This card is moving with velocity, let 2 meters per second. Card is moving with velocity 2 meters per second relative to this ground. Let this ball inside this card, let this ball moves with velocity 4 meters per second. That is observer 1. Observer 1 observes this ball inside this card, which itself is moving with velocity 2 meters per second. This observer observes ball moving with velocity 4 meters per second inside this card. Let this is east direction. East, west, north, south. So let this is east direction. So this is the scenario. We will represent all these velocity in standard term. So relative velocity is defined by an observer. As observed, relative velocity of object A relative to observer is nothing but velocity of object A as observed by the observer. In our general observations, relative velocity of an object, relative velocity of an object is its motion or its velocity as observed by the observer, as felt by the observer, as seen by the observer. That is the relative velocity of object relative to observer. Observer sees something and the motion of object as felt by the observer is said relative velocity of object with respect to observer. That is the simple definition, general definition of relative velocity. Relative velocity of A with respect to B is nothing but velocity of A as observed by the observer B. That is the simple definition of relative velocity. So here, based on this definition, we can say the velocity, relative velocity of B as observed by observer 1, it will be written as VB1. Relative velocity of ball with respect to observer 1 or as observed by observer 1 is 4 meter per second eastward. We can represent VB1, and this is a vector quantity. We all know this is a vector quantity. VB1, velocity of ball with respect to observer 1, with respect to observer 1 is 4 meter per second eastward. Similarly, velocity of this cart where this observer is sitting. This observer is sitting inside this cart. So velocity of cart and observer 1 will be same. We will assume this observer is sitting inside the cart stationary. So this observer and cart are moving with same velocity. So velocity of cart with respect to observer 2, we can say V12. That is velocity of cart or velocity of observer 1 with respect to observer 2 is 2 meter per second. That is also eastward. So we have represented both these velocity of ball with respect to observer 1, that is VB1, velocity of cart with respect to observer 2 or velocity of observer 1 with respect to observer 2, both will be same because observer 1 and cart are moving with same velocity. Their relative motion between observer 1 and cart is 0. So V12 is velocity of observer 1 with respect to observer 2 is 2 meter per second. So from your basic intuition, based general observation, now you can easily find velocity of ball with respect to observer 2. We have taken very simple example so that you can understand it properly. Otherwise, these are all vector expressions. So V1, how the observer 2 will see the ball, the motion of ball. If observer 2 observes the motion of ball, then this will be velocity of ball with respect to observer 2, or we can say velocity of ball as observed by observer 2. In simple term, relative velocity of ball with respect to observer 2, that is V2, velocity of ball with respect to observer 2, which will be velocity of ball as observed by observer 2. So you can easily say that ball is moving with respect to this cart 4 meter per second and cart is moving with 2 meter per second eastward direction. So velocity of ball with respect to observer 2 will be velocity of ball with respect to this cart plus velocity of cart with respect to observer 2. So from a basic intuition, you can say velocity of ball with respect to observer 2 is velocity of ball with respect to observer 1 plus velocity of 1 with respect to observer 2. This is very simple to imagine velocity of ball with respect to observer 2. That is relative velocity of ball with respect to observer 2 is relative velocity of ball with respect to observer 1 plus relative velocity of observer 1 with respect to observer 2. This expression is called relative velocity addition law. Relative velocity addition law. This expression. We have written this expression for very simple problem, but this expression is a vector expression. This expression is a vector expression, and it is true for motion in different direction. V1 maybe some in east-west direction, V12 can be in southeast direction, V2 can be in some other direction. They need not to be collinear vectors. Here we have taken collinear vector in eastward direction for simplicity. But this vector addition rule, relative velocity addition rule, holds true for velocities in any direction. This is a general expression, and it is true for velocity in any direction. So this relative velocity addition law holds true for velocities in any direction, whereas we have found it for collinear direction in one direction only, so that it can be understood easily. So this is the first rule of relative velocity. It is very easy to remember. Velocity of v with respect to 2 is velocity of v with respect to 1 and velocity of 1 with respect to 2. So you can easily eliminate these middle terms. This 1 will be eliminated, and v2 is the remaining expression. v and this 1, these are the middle terms. You can say they will merge as per this law, relative velocity addition law. These middle terms will merge and disappear. Only the end terms, that is v and 2, will remain in final expression. So this is easy to remember. Just eliminate middle term and write end terms in final velocity. So this rule is called velocity addition rule. This can be written as VAB is equal to VAC plus VCB. So this C will merge, it will be eliminated. Only end term A and B are remaining. So that is the simple, easy to remember relative velocity addition law, addition rule. That is how we add relative velocities. Now we will understand this relative velocity addition rule from different perspectives. So based on this relative velocity addition rule, we can say VB1 is 4 meter per second, V12 is 2 meter per second. So VB2 is 6 meter per second. That is velocity of ball with respect to this observer, or velocity of ball as seen by observer 2 or as felt by observer 2. Whatever you can say, relative velocity of b with respect to 2, observer 2, ball is moving with respect to, with speed 6 meter per second with respect to observer 2. This we have calculated from velocity addition rule. This velocity addition rule can be written in different way, and that is also frequently used in relative velocity, that formula. So this before writing this relative velocity rule in different form, other form, I will also discuss one more thing with you. You can easily imagine this V12, that is velocity of 1 with respect to 2 is equal to minus V21. because velocity is a vector quantity. So V12, velocity of 1 with respect to 2, or velocity of object 1 as seen by observer 2, that it has some specific value and direction. So when velocity of 2,1, you will find velocity of 2,1, that is velocity of 2 with respect to 1, that is opposite. So naturally the velocity of 2 with respect to 1 will be same in magnitude but in opposite direction. That you can easily imagine. Just imagine that. See, in this example you can understand it easily. This cart is moving with respect to ground with 2 meters per second. That is V12. This observer is moving with respect to observer 2 with 2 meters per second each direction. So the vector form, it will be written as this vector. This is vector V12. Magnitude of this vector is 2 meters per second in each direction. So V12, that is velocity of 1 with respect to 2, is 2 meters per second eastward, represented by this vector whose magnitude is 2 meters per second and direction is toward east. Now from this rule we want to find V21, that is velocity of this observer relative to observer 1. This observer sees that this observer is moving in eastward direction with 2 meters per second. Similarly, this observer will feel that this observer is moving with 2 meters per second in west direction. This will move in west direction relative to observer 1. So this observer is moving in west direction with same speed, that is 2 meters per second, but its direction is opposite. So V21, that is velocity of 2 with respect to 1, is also 2 meters per second but in west direction. So we can say we will represent V21 vector. V21 is represented by this. This arrow will be in west direction, that is west direction. This vector is V21 and its magnitude is also 2 meters per second, but its direction is toward west. So V12 is this vector and V21 is this vector. So from here you can easily say that V12 vector V12 is equal to minus vector V21. So that is the relative velocity of 1 with respect to 2 and relative velocity of 2 with respect to 1. They are same in magnitude but they are opposite in direction. So when we change these terms 1, 2, velocity of AB, VAB is equal to minus VBA. That is always true. From a basic observation you can easily understand it. V12 will always be equal to V21 with negative direction. So these vectors are negative vector, opposite direction, V12 and V21. Both vectors are same in magnitude but opposite in direction. Or we can write in vector form, V12 is negative vector of V21. So these two important rules of relative velocity we have discussed till now. One is velocity addition rule and second is negative velocity rule, that is V12 is minus V21. So we have written velocity addition rule as VB2. Here observer 2 was available present. VB2 is equal to VB1 plus V12. That was velocity addition rule which we have discussed. We can interpret this velocity addition rule from different perspective, and that is also very important, which is used frequently in many problems of physics. Again, we can write this expression as VB2 is equal to VB1 minus V21. VB, because V12 is equal to minus V21. These vectors are, they are all vectors. I am not writing every time this arrow term, but you should you know that velocity is a vector quantity. So I am not writing every time arrow. So these two vectors are negative vectors. So I have written V12 as minus V21. This is also very important equation of relative velocity. Here what you see, velocity of ball with respect to 2 is equal to velocity of ball with respect to 1 minus velocity of 2 with respect to 1. So here this middle term doesn't merge. Here you can simply write VB, velocity of B minus velocity of 2, whereas VB and V2 both are relative to a common reference frame, that is 1. Again I will repeat, VB2 can directly be written as VB minus V2. Velocity of B minus velocity of 2 with respect to common frame. Any common frame. It can be any common frame. It is not necessarily frame 1 or observer 1. It can be any common observer. That is, here that common observer is 1. Observer 1. So VB relative to 2 is velocity of B with common observer 1 minus velocity of 2 with common observer 1. Or simply to remember, for remembering purpose, VB minus V2. Just put minus sign here. For remembering purpose, put minus sign here. VB minus V2. VB minus V2, where VB and V2 both are velocities relative to a third common frame. Third common frame, here it is 1. So velocity of A with respect to B is VA minus VB. Simply you can say velocity of A with respect to B is VA minus VB, where VA and VB are velocities relative to third common frame. Common frame. So this is also very important equation. Now we will find VB2 with this equation. So what is given? We have to find VB2. VB1 is given. V21 we have to find, whereas we know V12. So these all always vector rules of addition. Just remember, they are not simple algebraic rules. They doesn't obey. They do follow the rules of vector addition. So V21, we have to find V21 because V1 is known to us, 4 meter per second eastward. V21 is equal to, we know, minus V12. We know vector V12. Vector V12 is equal to 2 meter per second eastward. So vector V21 is 2 meter per second westward, because it is minus V12, which we have discussed earlier. So V21 is a new vector in west direction. That is, we will write here separately V12. V1 is 4 meter per second. That is vector 4 meter per second. This is V1. Similarly, V21. V21 is this vector in west direction 2 meter per second. This is V1, V1, this is V1. V21, this is V21. Now we have to reduce vector V21 from V1. To reduce a vector, we know that when we are reducing a vector, we can simply add opposite of that vector. V1 is this vector minus V21. V21 is this vector. To reduce it, we have to reverse that vector. That is, this is minus V21 and this is V1. This is 2 meter per second. This vector is V21 minus V21 or V12, we can say simply V1. But here we are solving problem from this formula. That's why we are writing this vector 2 meter per second as minus V21. So we are simply adding VB1 plus minus V21. So this is V1 plus minus V21 is equal to V2. We are adding finding VB2, velocity of ball with respect to observer 2, by subtraction rule. VB1 is known, minus V21, we have derived vector minus V21 because V21 is toward west. This is actually V21 vector in 2 meter per second magnitude of. This is V21, hence opposite of this vector, that is this, is V minus V21. So when we will add VB1 and V minus V21, this is 4 plus 2 is equal to 6 meter per second. So in this way, we have found velocity of ball with respect to observer 2 as 6 meter per second, which is same. Naturally, it will be same, you know. It will be same as we have earlier calculated with addition rule. This addition rule is 4 plus 2 is equal to 6 meter per second. From this addition rule, V1 was 4 and V12 was 2. So both back addition, we have simply added because both are in same direction. We have not followed vector rule because for vectors in same direction they can directly add it algebraically. So here we have directly added 4 plus 2 is equal to 6 meter per second. But by this formula we have used vector addition rule so that it can be explained properly. By this formula also it is coming 6 meter per second. By velocity addition rule it is 6 meter per second. So you will say, why you are using this complicated formula? This simple formula was there, 4 plus 2 is equal to 6. Then why we need to find minus V21, then again reverse vector to add that? This is very lengthy process. But in some problems, you will find this formula as short formula and this formula will be lengthy. So we will take that example also, where subtraction formula is short and addition formula is lengthy. Addition formula is lengthy. So just change the problem slightly. Let this ball is moving in this frame, ground, with 4 meter per second. Same direction. So observer 2 observes this ball is moving with 4 meter per second in each direction. So what will be the velocity of ball with respect to observer 1? So just see what we have given. V ball. So V2 is equal to 4 meter per second. That is given eastward. This is given V2 ball velocity with respect to observer 2. V12 velocity of 1 with respect to 2 is 2 meter per second eastward. What we have to find? V velocity of ball with respect to observer 1, that is V1. So here you will see the subtraction formula is simple and addition formula is lengthy. By subtraction formula you can easily say VB1 is equal to VB2 minus V12. VB2 is given, V12 is given, V212. So this V1 can directly be found by subtraction formula, whereas with addition formula you cannot directly apply the addition formula here in this problem. So from this formula VB2 is 4 meter per second, or this vector, you can say this vector 4 meter per second eastward, minus V12 is also in eastward direction. So minus, we need minus V12. Minus will be reverse direction. That is V minus V12 is equal to this vector 2 meter per second. Because V12 is this vector, east direction 2 meter per second. That is V12. And VB2 is also in east direction, so this is given. But in this formula, we have to find minus V12, because for subtraction of vector, we add negative vector which is being subtracted. So minus V12, to reduce this vector V12, we will add vector 21. Vector 21, or we can simply write it vector minus vector 12. Vector 12 is 2 meter per second in each direction. So minus 12 will be reverse of this, that is 2 meter per second in west direction. 2 meter per second in west direction. Now we have to add both these vectors. So just add them. 4 meter per second, 2 meter per second. This is minus V12 and this is V2. Both vectors are in opposite direction. So this resultant vector is 4 minus 2, that is 2 meter per second in east direction. That is, this is the resultant vector, and this is V1. That is velocity of ball with respect to observer 1, VB1. So here subtraction formula is useful and short. So it depends on situation where you have to use subtraction formula. You can use any formula, addition or subtraction, but you have to manipulate that. But for certain situations, this formula directly gives you relative velocity, and for certain other situations, this formula will directly give you the relative velocity. Whereas relative velocity you can find by this as well as this for any problem. But based on problem, it will be lengthy with this or this. So you have to see which formula you can use. So you can directly get the relative velocity. Whereas both formula are same, that we have also discussed when we were discussing about addition rule. This is just another interpretation of this formula. Both formula are exactly same. These are same vector expressions. Both are same vector expression, but one vector has been reversed and new expression is subtraction formula, whereas original expression is addition formula. So we have discussed relative velocity with two formula, that is law of addition of relative velocity and law of subtraction of relative velocity. Now we will interpret this subtraction formula in another practical way. We will interpret this subtraction formula. So from subtraction formula, you know VAB is equal to VAC minus VBC. Velocity of A with respect to B is equal to velocity of A minus velocity of B, where both are relative to common frame, third common frame C, that we have discussed in relative velocity formula, subtraction formula. Let us convert this formula in general observation, and then you will appreciate how this formula can be used when you change your observation from different frame. We will discuss what is frame in our next topic. So you just understand a frame is a system which is moving with velocity, or it may be a stationary system. It's a system consisting space in x, y, z directions. Frame is nothing but a system of space in x, y and z directions, and this system may move with velocity or may not move with the velocity. So there may be different frame moving with different velocities. Observer can sit in any frame and observe the motion of object. So frame is nothing but a system of Cartesian coordinate x, y, z axis, and these coordinate system may be moving and may not be moving. So that is the frame of reference. We will discuss in our next topic. So there is observer. We will interpret it, find a short conclusion what this expression actually gives us. This is observer 1. This observer, this is a ball. This ball is moving with velocity v. Let there is another observer 2, and this observer is moving with velocity. Let this velocity is a. So just for understanding purpose, a velocity. This is fixed stationary observer, and this observer sees ball is moving with v in each direction. This is another observer who is moving with velocity a, or we can say that this observer is sitting in a separate frame which is moving with velocity. This is a frame which we have discussed. It's a set of x, y, z coordinate system. Frame is nothing but a set of x, y, z coordinate system which may or may not move. So this is a frame, and this frame is moving with velocity a in each direction, and this observer is sitting in this frame, this moving frame, or we can say this observer is moving with velocity a, whatever you want to say. Observer is moving with velocity a, or observer is sitting in a frame and this frame is moving with velocity a. So from this equation we want to find velocity of ball with respect to observer 2. VB2 is equal to VB1, velocity of ball with respect to observer 1, minus V21. So this subtraction formula gives us this result for this problem. Velocity of ball with respect to observer 2. Velocity of ball with respect to observer 2 is velocity of ball respect to observer 1, velocity of ball with respect to observer 1 minus velocity of observer 2 with respect to observer 1. This is the subtraction formula, and this will be v1, velocity of ball with respect to 1 is v, minus velocity of 2 with respect to 1 is a. So we can say v2 is equal to v minus a. This gives a very important conclusion when we change our frame of reference. When we change our frame of reference. So you can say in this frame where observer 1 is sitting, velocity of ball was v in each direction. When this observer, you can indirectly say when this observer, same observer sits on this frame which is moving with velocity a. Here we have assumed a different observer, but you can also say that same observer runs and changes his frame from ground to a moving frame which is moving with velocity a. Then the same observer, this observer will become observer 2. Observer 1 sits on this moving frame and this observer becomes observer 2. Now this observer, same observer who was sitting here, now he has sit here, and this, then he observes that same ball is moving with velocity v minus a. So the ball is same and its velocity is same. Only the observer has changed his reference frame. Observer 1 was sitting on ground and same observer sits here, he becomes observer 2. Same person, this is person was sitting here and same person runs and sits on a moving frame with velocity a. Then he observes that velocity of ball is v minus a, whereas on ground he was observing velocity was v. So what this observation, actually this is, I have explained for very simple example where both were moving in same directions, just for understanding purpose, but these are vector equations and they are true for vectors in all directions. Just remember, these vector equations are true for vectors in any direction, not only in one direction, which we are discussing here. We are discussing one direction only to understand properly, whereas these vector equations are true for vectors in any direction. 360-degree direction, vectors can be in any direction. So v2 is v minus a. We see, so what conclusion we draw? We draw the conclusion that when a observer changes his reference frame, which is moving with velocity v, velocity a, then the observed velocity or observed motion of the same object will reduce by a velocity minus a. Again I will repeat. When a observer was observing a ball and he changes his frame which is moving with velocity a relative to previous frame. A is the velocity relative to previous frame. So then observer changes his frame and sits in a frame moving with velocity a relative to earlier frame. Then motion of object which was being observed from earlier frame will reduce by velocity a, is motion of moving frame. That is the conclusion. When you changes your frame, then motion, to understand the motion of object in new reference frame, you have to add a negative velocity of moving frame in that object to understand and analyze the motion of object. That is the conclusion drawn with this formula. I will again repeat, when we are observing certain object from this frame, that is ground, we are observing motion of certain frame. And when I sit on a bus which is moving with velocity v with respect to this frame, with respect to my earlier frame, I sit on a bus which is moving with velocity v. Then from that bus, I have to analyze the motion of same object. Then I have to reduce a velocity of bus from that object. Again remember, you have to reduce the velocity of bus from actual velocity of object to analyze the motion from bus. That is the reason when we change the frame, we add a minus v velocity with original velocity of object, where v is the velocity of moving frame. We have to add minus v velocity. You can say like this also. You can add minus v velocity or reduce the velocity of bus from velocity of object to understand the motion of object from moving frame. So that we will understand the help of an example. So we will discuss a very simple example of relative velocity when we changes our frame of reference. When somebody changes his frame of reference, then how the new motion of object is analyzed. So this is observer sitting on the ground. This observer sees that this ball is moving with 2√2 meter per second eastward direction. This is east, west, north, south. This ball is moving relative to this observer with velocity 2√2 meter per second in east direction. Now a car, this is car, which we will use as a moving reference frame. This car is moving towards east to north, 45 degree east to north, 45 degree from east towards north with velocity 2 meter per second. So when I changes my reference frame from ground to this car, now I have jumped on this car. From here I want to observe the motion of this ball. Then what will be the velocity of ball with respect to this new reference frame where I have changed, where I have arrived. So this is my old reference frame, this is my new reference frame moving with velocity v in east-north direction. So from our relative velocity formula, that was subtraction formula, we have concluded that when we changes our frame, then in new frame we have to add the minus v velocity, that is where v is the velocity of new frame. We have to add a minus v velocity in the velocity of object to analyze the velocity of a motion of object from new frame. Again I will repeat, when I changes my frame from ground to car, which is moving with 2 meter per second velocity in east-north direction. So I have to reduce the velocity of moving frame from velocity of ball to analyze the velocity of ball from this new frame. That is the rule, velocity subtraction rule. Physical general interpretation of subtraction rule. When I changes my frame from ground to car, I have to reduce, and this ball was moving with this velocity from ground relative to ground. Then to observe the same motion of ball from moving car, I have to reduce the velocity of car, that is 2 meter per second in east-north direction, from velocity of ball. So what will be how the ball will carry out its motion relative to this new reference frame, that we will find. So ball's velocity is 2√2 per, this is a vector 2√2, that is velocity of ball, and the car is moving in this direction, east north direction. So we have changed the frame to analyze ball from new frame, this vector, that is velocity of moving frame, we have to reduce velocity of moving frame from velocity of ball. This was the velocity of ball. So let this is the velocity 2 meter per second east north. So this vector, reverse of this vector is just make this axis system. So this is velocity of ball. Let it is Vb. We have to reduce velocity of moving frame, that is opposite vector. This is minus Vf. F means frame. Minus Vf. So this is velocity of ball and this was velocity of moving frame. So minus vector is in reverse direction, that is minus Vf. This was Vf. Velocity of frame. Velocity of frame, that is car, is this. So minus Vf is this, reverse of this vector. So this angle will also be 45 degree because this was 45. And this is 2 meter per second. Now we have to add both these velocities. We are going to add both these velocities. Or we can say we are reducing velocity of frame from velocity of ball. Whatever you want to say, you can say. Or we are adding minus velocity of frame with velocity of ball. That way you can also say. So just divide the components. In this direction 2 meter per second, in this direction its component is 2 cos 45, that is 1 by root 2, and in this direction is component 2 1 by root 2, that is 2 sin 45 degrees. This angle is 45 degrees. So this component is 2 sin 45, this component is 2 cos 45 degrees. So this is 2 by 1 by root 2, that is under root 2, and this is also under root 2. So resultant vector you can write it like this. This vector is 2 root 2, this is under root 2, and this is also under root 2. So net vector in x-axis direction is under root 2. In eastward direction you can say under root 2. 2 root 2 minus under root 2, that is under root 2. And this vector in perpendicular direction is under root 2. Resultant of this and this vector, that is this. And this is resultant vector r. Let this is resultant vector. R is under root 2 plus 2 is equal to 2 meter per second. So this resultant vector is nothing but velocity. Resultant vector is nothing but Vb minus Vf, and let this frame is 1, Vb1 minus Vf1. So we have seen that, and the direction of this resultant vector, from easily you can see this will be 45 degree, and this is south, this is east. So velocity of ball with respect to this moving car is given by this vector having magnitude 2 meter per second and direction 45 degree from east to south, and this velocity is velocity of ball with respect to car. velocity of ball with respect to this moving frame. So what we have done, we have just reduced velocity of moving frame from velocity of ball. This is a short and quick technique which you can remember. Just reduce velocity of moving frame from velocity of object. Then you will get velocity of object with respect to moving frame. So when I was seeing from ground velocity of ball 2√2 meter per second, 2√2 meter per second in each direction, when I change my frame and I have taken the seat on this car, then to analyze motion of the same ball from this car, I have to reduce velocity of this car from velocity of ball. That is this Vf. F is the velocity of frame with respect to ground. Velocity of this car with respect to ground. This is Vf1. Vf1. Velocity of car with respect to ground. So just reduce velocity of moving frame from ball. So we have taken minus Vf1. This is minus Vf1. Vf1 was in this direction, east north. So V minus vector will be reverse in this direction. Minus Vf1. So we have reduced velocity of car, that is this velocity, from velocity of ball, that is this velocity. And then this is 2. We divided this vector in these components. 2, and this angle was 45 degree. After dividing the vector in components, we got resultant vectors √2 in each direction and √2 in south direction. And the resultant vector of these √2 and √2 by simple Pythagoras theorem, we found 2 meter per second in east-south direction. So that is a quick way which follows velocity subtraction rule, relative velocity subtraction rule. But it is very quick and easy to understand. When we change our frame, then just reduce the velocity of moving frame from velocity of object which is being observed. That is, you have to remember.